Everybody, thanks for having me. I'm so excited and honored to be back in Birmingham and helping to kick off this brand new developer track here at SLOSS.tech. Like Michael was saying, it's been a long time coming from the inception of Base to working with Tech Birmingham, and to finally see this come to light or come to fruition is awesome. So I'm so excited to be here, and I can't wait to dive into some tech here today. So I see a lot of friendly faces out here. It's been great to catch up with folks that I haven't seen in quite a while. For those of you that don't know me, I'm David. I spent about 5 years here in Birmingham, but I moved back to my hometown of Dallas in Texas about 5 years ago. But I spent my kind of formative years as a developer here in Birmingham. So it's got a really special place in my heart. And yeah, I'm getting a little choked up just thinking about it. But a little bit about me. During my time here in Birmingham, I worked at several companies. Most recently, I was the CTO at a company called Windy that some of y'all may have heard of. I was there for 7 years and left at the end of last year to kind of pursue some of my own things. In particular, a few kind of startup ideas of my own, as well as starting some consulting and contracting work, helping other startups kind of get off the ground and figure out how to leverage technology in their businesses. Other than that, I've been spending a lot of time with my kiddos and just really trying to keep up with this rapidly evolving landscape of AI that we're all seeing kind of take over everything, tech and business, and you know, eventually probably the world, probably kill us all at some point, but hey, we're here for now. So before we dive in, I have some words from one of my sponsors. This slide was gonna have some more dramatic effect with the sound and whatnot. Unfortunately, we couldn't get that working, so I'll just talk over it a little bit. But this is supposed to be a little commercial from our sponsor, Cyberdyne Systems. They're working to help us build a better future and make sure that you know, the AI is here to protect us and take care of us in these changing times. So the video had way more impact, but I'll just kind of skip over that. On that uplifting note, let's dive right in. So today we're going to talk about TypeScript, or as I like to call it, the mother tongue of the AI apocalypse. And thanks to Cyberdyne Systems for a pretty sick logo, right? Maybe a little terrifying, but that's okay. I know everybody's favorite language is TypeScript, right? Like, we don't work with other technologies, right? Everybody loves it. Probably not. But has anybody in the past year or so gotten on this whole vibe coding bandwagon? Can I see a show of hands? Has anybody vibe coded an app? I see a few. I know the rest of y'all are lying. Everybody's tried it. But when you wrote those vibe coded apps, you may not even know, but if you do, can I see a show of hands of how many vibe coded apps were generating TypeScript to make their apps? Once again, see a few hands. The rest of y'all are lying. So why is that? Well, to understand that, we need to dive into a little bit of a history lesson. So we'll jump back to the early days of the internet and take a look at the inevitable uprising of TypeScript in AI. So we start our journey in the good old 90s. AI was the stuff of science fiction, and humans dominated the tech industry. So the year is 1995, and Netscape gets bored of just plain old static and HTML, CSS pages. So they decide that they're going to add a programming language to the new browser that they were working on. They hire this guy here, Brendan Eich, to embed the scheme language into their new Netscape Navigator browser. But wouldn't you know it, they quickly realize that Java is all the rage these days and decide that, you know what, Brendan, instead, why don't you build a language more like Java? So you gotta love those last minute change requests, right? So you're ready to come in and do one thing, and then the business decides it needs other things. So what does Brendan do? He goes on a 10-day coding binge, mashing out a hodgepodge of a language to add some fun interactivity to this new fangled invention called a web browser. We've all been there before, right? 1 minute you're opening up your computer, sitting down, grabbing an interesting looking ticket from Jira, and then all of a sudden management's breathing down your neck about how this is the most urgent priority and it's already somehow 37 weeks late, all the while sending over contradictory change requests every 2 minutes while you're just trying to stay in a flow state. Can we just get a little space, please? Before you know it, a week's gone by, you haven't showered since Tuesday, your desk is littered with Mountain Dew cans and Cheeto dust, and somehow you've shipped a half-baked piece of software that the entire world is going to rely on for the rest of time as we know it. Gotta love ADHD, right? So then in September 1995, Brendan's little language, at the time it was called LiveScript, ships with a beta version of Netscape Navigator. Then in December of 1995, Netscape Navigator is officially released with support for what is now known as JavaScript. Little does Brendan know at this point that his little language is soon going to shift the entire course of humanity. Shortly afterwards, in 1996, Microsoft comes along with their Internet Explorer browser and add JScript to Internet Explorer to keep up with the features of Netscape's new Navigator browser. As we all know, Microsoft quickly takes over the browser market by shipping Internet Explorer shipped on their popular Windows operating system. We know about the monopoly lawsuits and everything else that ensues. But keep an eye on these Microsoft folks. We're going to see quite a bit of them later on. So over the next several years, Netscape and Microsoft duke it out in what would be known as the browser wars. During this time, JavaScript remains a little more than a toy feature of these major browsers, while proprietary solutions, Java applets, Adobe Flash, and Microsoft Silverlight dominate the domain of web applications. Y'all remember those days, right? A lot of fun, maybe a little awful too. In the background, though, there's an army of open source wonks secretly conspiring to turn this little language known as JavaScript into a full-fledged enterprise-ready application development platform. Gotta love that, right? So in 2005, Jesse James Garrett coins the term AJAX in a white paper that describes a set of technologies built on JavaScript that could be leveraged to create what would be known as web applications by allowing data to be transmitted in the background, which would avoid the need for full-page reloads, creating a more responsive and interactive user experience akin to the desktop applications of the day. So from this set of ideas, the first wave of JavaScript tooling bursts onto the scene. Libraries like Prototype.js, MooTools, and most famously jQuery, I'm sure all of us old hat developers have all worked with that at some point, would go on to dominate web development for the next several years. Meanwhile, browsers begin to implement improved developer tooling, so things like Firefox's Firebug and Safari's Web Inspector come to fruition during this time. Then in September 2008, Google debuts the Chrome browser. I think we all are familiar with that. The big deal with Chrome was that it had a built-in V8 Java engine that included just-in-time compilation, which was a major step towards making the browser's application runtime performant enough for more demanding tasks, all powered by JavaScript. It's also around this time that HTML5 is standardized along with the already established CSS3 standards and the dawn of what we call Web 2.0 starts around this time. In December of 2009, all these parties come together to define what would be known as ECMAScript 5, which is essentially the set of standards that would codify JavaScript's feature set. This is sort of the start of JavaScript's maturation from a toy language into a serious development environment. Around the same time, a little-known Ruby developer named Ryan Dahl is hacking away on bringing the JavaScript language to the server. In May 2009, he releases Node.js, further expanding JavaScript's reach amongst developers. And then shortly after, in January 2010, Isaac Schutler releases NPM, which sets the stage, along with Node, for the proliferation of JavaScript into every corner of the earth. All of these factors lead to an explosion in front-end centric web frameworks. These are built on the new capabilities of the browser and the performance enhancements that just-in-time compilation brings. At this point, we get a new set of web frameworks. Backbone.js, AngularJS, and Ember appear. Backbone and Angular show up in 2010. Ember shows up in 2011. A ton of developers jump onto the bandwagon of this whole idea of front-end development. New career paths are formed and opportunities open up for developers to build complex interactive web applications delivered through the browser. Meanwhile, a lot of or the typical web frameworks of the time, things like Ruby on Rails, .NET MVC, and Django, shift their focus more towards an API-first approach, while the popularity of Express.js, which is built on top of Node, which is also JavaScript, increase due to the simplicity that it offers in creating these new back-end APIs. Then in May of 2013, React is open sourced by Facebook at JS US. Sorry, getting my words tangled up. Adoption quickly takes off for React, and by 2015, it's squarely seated on the top of the front-end framework hierarchy. It's the most used web framework to this day. It really kind of changed how we think about web development and in particular front-end development. And this is backed up by several sources, such as the State of JavaScript survey, the Stack Overflow dev survey, and others. Around the same time, July 2013, Electron is released, leading to the rise of JavaScript and TypeScript for desktop applications. Also the death of everybody's computer memory. So at this point, we have JavaScript on the web, we have JavaScript on the server, and we have JavaScript now being used to develop desktop applications. Shortly thereafter, I told you to pay attention to these Microsoft guys. In 2014, they quietly released TypeScript 1.0. TypeScript originated from the shortcomings of JavaScript for developing large-scale applications, in particular at Microsoft, alongside a lot of their customers. The tooling that TypeScript brings to JavaScript includes things like type signatures and annotations, compile time type checking, type inference, interfaces, enumerated types, generics, namespaces, tuples, and explicit resource management. All of these things were things that were lacking in the current set of JavaScript tooling, enabled Microsoft to build much more robust applications. In addition to all those new features, TypeScript retains compatibility with the ECMAScript 5 standard, so it was able to play nicely within the quickly growing JavaScript ecosystem of tools. At the time that it was released, it received a lot of praise from the enterprise developers, folks writing C#, .NET, things like that, while developers coming from languages like Ruby on Rails, Django, and things like that, just saw it as added complexity and were sort of averse to the idea of types or strong static types versus the dynamic typing of those languages. Then, in March 2015, JavaScript makes its way to mobile via React Native. At this point, JavaScript has gone from this little toy scripting language for the browser used to make little bits of website interactivity to potentially the most portable, pervasive language on the entire planet. A year and a half later, in 2016, Google releases Angular 2 with TypeScript as the default language, bringing TypeScript into prominence as the standard for web development. Shortly thereafter, the other major frameworks of the time, React and Vue, follow suit and add TypeScript declarations to their packages. A massive wave of developers that were raised on the freedom and chaos of Ruby and Python all of a sudden start to see some of the perks of statically typed compiled language like TypeScript and start to adopt it into their practices, in particular for front-end web development. Since then, 2020 to today, as JavaScript and TypeScript continued to grow, money became part of the picture. In 2020, Vercel received $21 million in a Series A to build upon its Next.js framework, and the associated infrastructure is building out. The VCs see the dollar signs and they follow suit, and so they kick off a trend of funding other for-profit but open source platforms, including Prisma, which has received over $50 million in funding, N8N, which has received over $70 million in funding, Apollo, a platform for GraphQL, has received over $150 million in funding. You have Supabase, an alternative to the very popular Firebase by Google, has received over $400 million in funding, and Vercel, that we mentioned before, is over $500 million in funding now. So the money is in TypeScript. Not to mention some of the major players, React and GraphQL are backed by Facebook, Meta, whatever you want to call it. And then we have VS Code with those Microsoft guys that I told you to pay attention to. That's just the first side of the story. Phase 2 is the rise of the machines. We'll make like a Terminator and head back in time just a little bit and get us caught up on what's going on the AI side of things. So in December 2015, OpenAI is founded by the likes of Sam Altman, Elon Musk, Ilya Sutskever, along with corporations like AWS, Infosys, and Y Combinator. A total of $1 billion is pledged to OpenAI to start this new company. At the time, OpenAI's founding mission is to ensure that artificial general intelligence, by which we mean highly autonomous systems that outperform humans at most economically valuable work, benefits all of humanity. So, great principle, trying to protect the humans from the AI. This is particularly motivated at the time by Sam Altman and Elon Musk, who had significant concerns about AI safety and its existential threat to humanity. We've seen how that's gone since then, but we'll get to more of that later. So once again, pay attention to Microsoft. In 2018, Microsoft acquires GitHub. Why is this a big deal? So as of January 2023, GitHub has over 420 million repositories hosted on its site, with at least 28 million of those being public. It has over 5 billion developer contributions and over 500 million open source projects in 2024 alone, demonstrating that GitHub is sort of the source for all of our code, or the host for all of our code. 2019, once again, Microsoft back in the picture, partners with OpenAI. For those of you that don't know, on the left, we've got Sam Altman on the right, or got this backwards, right? Sam Altman, left, Satya Nadella, who's the CEO of Microsoft. As I like to refer to them, Emperor Palpatine and Anakin Skywalker. So Microsoft invests $1 billion into OpenAI in 2019 to support the responsible AI initiatives that they're pursuing, and also to allow OpenAI to leverage Microsoft's Azure cloud infrastructure. We see how the responsible part is going, and this sort of kicks off the transition of OpenAI of a responsible, human-focused initiative into possibly more of a profit-seeking initiative, which has been highlighted in recent years by the departure of key figures like Ilya Sutskever, who was sort of the brains behind ChatGPT. So then, GitHub, now owned by Microsoft, in 2021, they opened a technical preview of GitHub Copilot. And then in June of 2022, GitHub Copilot announces general availability. Who here is a developer and has used Copilot? So we're all familiar with it. We've seen the potential. I think most of us probably can't live without it. This, for the non-developers in the room, was sort of the first sign that this AI thing was real. It wasn't just something that people talked about in academic papers, but oh my gosh, all of a sudden our tools are thinking for themselves, and this is something different than just autocomplete or help with debugging. Then we get to Judgment Day. November 30th, 2022, OpenAI is released in a free preview from OpenAI. I think we all probably remember that day. All of a sudden, AI was real. We could talk to it. It was not just, once again, the developers had a little bit of a preview with things like Copilot, but all of a sudden we were having long conversations. It displayed characteristics of thinking and being able to implement logic and think through workflows and whatnot. And it essentially changed the course of everything that, or the path that we're on to this day. Once again, Microsoft comes back into play. January 2023, shortly after ChatGPT's release, invests another $10 billion into OpenAI to help with the growing need for the Azure cloud infrastructure that's powering these AI systems. Work also begins at this time to integrate ChatGPT into many of Microsoft's core products. So since then, we have the dawn of the LLM. In 2023, Microsoft, like I mentioned, they start to incorporate ChatGPT, and they take the GitHub Copilot theme, and now they have a Copilot for everything. At the same time, or around the same time, the AI-powered editor Cursor is released, which I know many of the developers in the room probably use even today, which Copilot was our sort of first iteration. Cursor brought the ChatGPT experience directly into our code editors, and all of a sudden, AI is writing our code. In 2024, every company is chomping at the bit to AI all the things. As we've seen, there's already preemptive layoffs going on as executives and other managers realize the potential and figure, why do I need all these humans? I've got an AI that can do all this work now. And then in 2025, this year, already Microsoft, once again, has announced the Majorana 1 quantum computing chip, which they believe will be viable in the next few years and will be a significant advancement to the way that we're able to leverage AI. Also during this time, the term vibe coding is coined. So during this time, a lot of us engineers, we start to lean more on these AI tools like Cursor and GitHub Copilot. There's even a trend recently of engineers saying, I've forgotten how to code. I just let the AI do it. I tried to get in the other day and I can't remember how to write Ruby or TypeScript or whatever. Alongside that, we've seen sort of some messes start to show up. Who here's reviewed a PR recently and you were like, that was AI. That was this guy does not know what they're doing. See a couple hands. Yep, it's everywhere. It's taking our jobs and rotting our brains. So now that we see where we're at, we've got AI, we've got TypeScript. Where do we go from here? So today, we're in what I like to call the vibe era. So everybody can code now, or at least they feel like they can. They've got some vibes. What is this vibe coding thing? So earlier this year, Andrej Karpathy, who's another co-founder of OpenAI and also one of the AI heads at Tesla for several years, posted a series of tweets about how he had essentially stopped trying to write code and just going with the vibes, letting the AI do the work. The term quickly took off, and he even recently proclaimed that English is the hottest new programming language on the market. He's not necessarily wrong. Sure, right now vibe coders are shipping bug-riddled, insecure apps at a very rapid pace, but the technology is also rapidly evolving, and a new breed of tools are showing up and making big bucks to empower everybody to ship their own apps without any coding knowledge required. This includes tools like Bolt.new, Replit, Lovable, and V0. If you haven't seen them, check them out, especially if you're a developer. They're getting better than you think. And guess what's at the center of it? You guessed it, is Microsoft, baby. Told you to keep an eye on them. No, seriously. TypeScript is at the core of all this. I asked y'all earlier who's vibe coded an app. Most likely, whether you knew it or not, it was writing TypeScript. Andrej was saying, English is sort of the hot new programming language, but really I like to look at it as an abstraction or a DSL on top of TypeScript at this point, given the state of our tools. So why is this? Before we dive into that, we'll need to look at the anatomy of an LLM though. So I'm not an expert on this subject. I've never studied machine learning or trained an LLM myself. But I did a little bit of research, i.e. I asked the AI how this all works, and this is what it told me. So the process of creating an LLM starts with data collection and preparation. As we all know, LLMs essentially are trained on the entire library of human knowledge, aka the internet, and that includes both public and private sources. Once again, told you to pay attention to those Microsoft guys. They acquired GitHub. There's all the open source code on GitHub, but they also have access to all that private code that you've got hosted there. So keep that in mind. So we go out, we collect a bunch of data, and we shove it into the LLM, which leads to pre-training. So at this phase, you have your LLM. It's essentially a mathematical model that is trained to analyze text and create probabilities and predictions between words. It's basically a bunch of math. At this point in pre-training, there's no human involved. So we've shoved all this data into the LLM, and it runs a bunch of computations to set a baseline sort of structure for how to essentially predict the next word and create readable text or code. From there, we get into fine-tuning. This is where humans get involved. They start to work with the model and tune it for specialized tasks, whether that be coding or how to work with law texts or medical texts and things like that. Several different techniques they use to do this. Sorry about that. The humans get involved, help to refine how the LLM works. There's some other steps. These are usually optional, but this includes reinforcement learning, where you put the LLM into a simulated environment and give it quote-unquote rewards for doing desired behaviors. And then from there, we have evaluation and iteration. and evolution of those models. So within this, what's important to note is as these LLMs go out and essentially eat the internet, they're going to develop an inherent bias towards a few different things. One, the quantity of data, so how much can it consume about a certain topic? And then two, what is the semantic connection between the data that it has, which is at the bottom here, the embeddings part. So the AI is able to make connections between certain words and understand how certain words or concepts are connected to each other. And it builds sort of its knowledge through that process. So what does all of this have to do with TypeScript? Well, LLMs seem to love TypeScript, and there's a variety of reasons for that. First off, like I mentioned, the availability of training data for TypeScript is huge. So that comes from several sources. Like I mentioned, OpenAI in particular having, or Copilot in particular, having access to those GitHub code repositories. It can train on tons of data. In particular, in this case, the vast majority of code on GitHub is JavaScript or TypeScript. So you've got that reinforcement of TypeScript as sort of being the default language. And then we also have explicit language semantics and types, which gets into those embeddings. So if you have a language like TypeScript that has very strong connections between the semantic meaning of the actual tokens in your code, that helps to reinforce those connections within the LLM's brain, so to speak. So it can see, like, I define a user object, and that is of type user. And it can sort of understand and make those connections on its own. In addition to that, we have the portability of TypeScript. So TypeScript is built on JavaScript. Like we went through in our history, JavaScript is everywhere. We can ship it to the browser, we can ship it to servers, we can ship it to desktop apps, and we can ship it to mobile. Don't know that there's another language that's able to do that, at least with the sort of capacity that JavaScript and TypeScript are able to do. Then we have the tooling. So in addition to the power of the LLM understanding TypeScript, these big corporations that have invested in things like TypeScript and GitHub are working very hard to deliver tooling that only reinforces that we use those languages to build our applications and software. From there, we have the community support. So TypeScript, JavaScript has a very active community. They're out there writing tutorials and documentation. I think TypeScript libraries have some of the best documentation sites in the world, for better or worse, at least when you hold it up against languages like Ruby or Python. So all of this feeds into the LLM and how we use it, and we end up with a situation where LLMs are churning out loads and loads of TypeScript applications every single day. So we talked a lot about that, but I know there's folks out there that don't just want to write TypeScript. So what do we do? How do we fight back against the mother tongue? So we'll take a look at Python first. Python's a bit interesting. So it's, as some of you may know, the language of AI research and development, machine learning. So it has a very close relationship to everything that's gone into the actual building and creation of LLMs. There are a few challenges with Python, though. So there's plenty of training data. I think alongside JavaScript, Python is number 2 in terms of languages on GitHub. And there's a wealth of articles and other things published on the internet. So the data to train LLMs on Python is there. Where it tends to suffer and where the tooling isn't quite as effective is the fact that Python lacks explicit language semantics and strong typing. Got a question mark there because technically you can write type annotations in Python, but a lot of developers hate it. They say it doesn't work. There's a variety of reasons for that. But essentially the community is kind of fractured on the issue, and there's tons of Python code that does not leverage those tools that could potentially help to better train LLMs on how a particular piece of code works. In addition to that, portability, not really. Python is mainly a scripting language. It's used a ton, like I mentioned, in data science, machine learning, heavily in academia with things like Jupyter Notebooks. There are server frameworks and things like that, but really Python is there for scripts and crunching numbers and data. On the tooling side, Python does pretty decently here, especially because of its proximity to the development of LLMs. The tooling's kind of been built out to work well with Python as well. Community support is another kind of question here. The Python community is very fractured in terms of the AI research and machine learning side versus like the web developers, and standards tend to vary quite a bit across how different users of Python tend to work with it. And then finally, financial backing, once again, because of its relationship with AI development, it's got pretty strong financial backing. So that's something in Python support. Then we get into the enterprise walled garden, as I like to call it. This is languages like Java, C#, C++, all those things that the government and banks and hospitals and things like that use, which leads to one of the big concerns and challenges of leveraging AI in these languages. So the availability of training data is a huge challenge because these industries where these languages are used are typically highly regulated, which leads to a lack of open source software, and even when you get into private proprietary enterprise software, these folks love to kind of operate behind the firewall, so to speak, and they don't want their code exposed to anybody, AI or human, that shouldn't have access. So the AIs have less of an opportunity to be able to kind of train on some of the most common use cases for these languages. On the flip side, they have great support for things like explicit semantics and strong typing. They're fairly portable, used from everywhere from desktop applications, mobile applications, embedded systems. So they do serve a wide variety of purposes. Once again, tooling is pretty good as well. Put a question mark by community support because, once again, these folks are typically not participating with the community at large, but rather sort of staying in their little walled garden and constrained by the regulations around their particular industries. But those industries make lots of money, so there is financial backing there to improve the AI's ability to work with these particular languages. Then we get one that hits close to home for me. Take a little reality check with Ruby on Rails. For those of you that don't know, I kind of cut my teeth on Ruby on Rails for several years, and I still love it to this day. It's got a lot of great things that I just haven't experienced in other languages and platforms. Unfortunately, Ruby is not on a good trajectory when it comes to AI assistants and LLMs. So what's good about Ruby? The availability of training data, in particular, given the size of the community, I think is very strong. The Ruby community has a very active user base that likes to publish articles and talks and documentation and sort of give back to the community. Unfortunately, that community is not very into things like explicit language semantics and strong typing. There have been advances with Ruby, in particular Ruby 3 introduced type annotations, and companies like Stripe have also opened open source projects like Sorbet that add explicit typing to Ruby, but they're not used very much. Kind of like Python, there's a small slice of the community that's into it, but a lot of Rubyists love their Ruby and the way Ruby is and the elegant code that it produces, and all that typing mess just kind of gets in the way. So that's going to be a struggle for Ruby working with AI. Portability, same thing here. It's pretty much a server-side language and a scripting language. Doesn't really do a whole lot with the browser. And Rubyists also have this weird thing with finding alternative workarounds to using web standard tools like JavaScript and HTML and whatnot. Instead, we end up with things like CoffeeScript and TurboLinks and Hotwire and a bunch of other tools that just don't really have the conventions and the crossover with the majority of data that the LLMs are trained on. The community is great though. So there is community support, and I know there's folks out there in the Ruby community that are actively working to enhance the LLM's understanding of kind of the Ruby way of doing things. Don't know how successful that's been. I know it's a very kind of small niche of the community right now, but I'm hoping that that will increase over time. And then once again, financial backing is a big struggle for Ruby. It's a little bit more of a niche language. You do have a few larger companies out there like Shopify, Stripe, GitHub, and got to give a special shout out to Birmingham's own Fleetio. That's done a lot to support the Rails community in the past several years as well. So there are some players, but they're no Microsoft. And then finally, we have the scrappy upstarts. This is an area that a lot of us developers like to tinker in. This is languages like Go, Rust, Zig. I know Elixir's pretty popular around these parts. I'd put that in this category as well. So a lot of challenges here as well. There's not a lot of training data, just given the newness of some of these languages, along with the smaller community and just kind of lack of documentation. On the flip side, some of these languages exhibit very strong characteristics in terms of their language semantics and strong typing that do provide an advantage in training LLMs and how to work with these languages. In terms of portability, it's going to depend on the language, but there are some opportunities here. I know Rust in particular is working on packages for things like mobile development and desktop development, game development even. So there is quite a bit of opportunity there. And in particular, I know there's been a renewed interest in WebAssembly, which allows you to write in these languages and then essentially ship it as JavaScript under the hood to the browser. So that could bring an additional opportunity to leverage these tools more and step away from JavaScript and TypeScript everywhere. In terms of tooling and community support, once again, it's going to depend on the language. The degrees vary, but I wouldn't say that any of them have incredibly strong tooling as it pertains to AI. but I would say a lot of these communities, while small and niche, are very strong and very active. So there's something to lean into there. Financial backing, as far as I'm aware, other than maybe Elixir, there's not a ton of money. I guess Rust is kind of getting there with some of the recent announcements around, I think the government is talking about moving everything to Rust, and there are other organizations with similar initiatives. So this brings us to a choice. You can take the blue pill and keep telling yourself this whole AI thing is just a fad and it's not coming for my job or the entire world. And that all those silly vibe coders just don't know what they do. Or maybe you are a vibe coder and you're good with just hitting tab and staying in blissful ignorance, hoping that the AI is going to fix that bug no matter how hard you bash your head against the wall. Or you can take the red pill and see how to eat the rabbit holes and learn how to fight back. So just like Arnold's T-800 in Terminator 2 was used to fight for humanity against the AI, we too can leverage AI to fight back against the swarm of TypeScript being generated by AI. How do we do that? So first off, this is something I've been tinkering with for the past few weeks, but I've seen a lot of folks writing articles and experiencing similar things to this. So one, as developers, we need to shift our mindset. I know we love to solve hard problems and get deep in the weeds of the code, but working with AI really requires us to put on our manager hats and look at the AI as less of a sort of a tool that helps us get our jobs done and more of a collaborator that we work with to accomplish the tasks that we're trying to accomplish. So in particular for me, my aha moment actually came outside of the realm of coding. I had been working with AI to sort of augment some work I had been doing with my therapist, and so I got the AI to sort of play a pseudo therapist for me, and just started chatting with it first to like, hey, how do I do this, AI? Like, how can you help me with my therapy objectives and goals that I was working on? And so it helped me sort of set up this sort of therapist assistant, and then I was able to interact with it and see results very quickly in terms of how I was working towards my goals and whatnot. So this gave me an idea. I went back to one of my side projects that I was working on, and I did the same thing. I said, hey, I'm working on this project. Here's the high-level idea. Not to toot my own horn, but as a former CTO, I kind of understand the full software development lifecycle and know that it's more than just jumping into the editor and writing code. So I gave the AI a little bit of context of what I was trying to build, and then instead of jumping right into the code, I said, I need a product manager. And I told the AI, like, hey, I need to generate a product manager. And we stepped through the process of setting up cursor rules and other things to generate a product manager. And I sat there with the AI for several hours and essentially spec'd out the entire app with my newfound product manager, and got probably the most detailed, comprehensive documentation I've ever had on a project. No offense to the product managers out there that work very hard at those things, but be careful. They're coming for your jobs. All that to say, we need to look at AI less of, like I said, just that hammer that we use to bash out code, and more of a collaborator that we can work with and have a conversation about our languages and how they can work with us effectively to write code. Next we have retrieval augmented generation. This is a big fancy term. Y'all may know it as RAG. I'm probably getting this all wrong, but essentially what RAG is a way to inject context into your prompts. It's often associated with things like allowing the AI to browse the web as you're working with it. And then also in tools like Cursor, being able to reference specific documentation and say, hey, you're working on this task, reference these files to ensure that you have all the knowledge you need to generate some code or documentation or whatever the case may be. We don't just have to reference code, though. We can generate READMEs. AIs love Markdown in particular, so as you're generating documentation, whether that's doc strings or separate Markdown files, RAG allows us to tell the AI the context that they need to be effective at their jobs, regardless of the language. And then finally, we have the nuclear codes, Model Context Protocol. How many folks have heard of this? How many folks actually understand it and know what it is? Got a few? Okay. So this is sort of like probably the gateway to unlocking a lot of things with AI beyond just sort of chat and generating some code and whatnot. So Model Context Protocol provides a standardized way for models to connect to data sources and tools. This includes everything from the file system and the command line. It can connect to the web and, in particular, third-party APIs, the different systems that you work with for project management or knowledge bases, things like that. It also tells AIs how to process things in memory, generate its own context, and work through a sequence of actions versus just trying to do everything in one shot. It also allows AIs to work with our dev tools. So some of y'all may have seen this in Cursor where the AI assistants can now get feedback from your linters, your static analysis tools, your debuggers, so that you're not just copying and pasting errors. It can see the error right there in the console and take action for you. The protocol itself is pretty simple. You generate a server, which can be a variety of things, and then essentially you define the particular tool that you're trying to work with with Cursor at least, in a JSON file that essentially tells the AI for this particular tool, here's how you access it, and off it goes. So this opens up a lot of possibilities to, even when the AIs or the LLMs lack the inherent training data from the internet at large, you can point the LLM to your specific code, your knowledge bases, so that as it's working, it's sort of got the context and the data from your sources versus just trying to draw from everything on the internet. So to recap, excuse me, keys to winning the fights. First off, that manager mindset. So treat your AIs like collaborators, not as a tool to be leveraged. I think you'll find promising results just having a conversation versus trying to just smash it into code. Probably most importantly, document. If you're writing code, everything from inline documentation, which I know it's always controversial with developers, it's like comments, no comments. All of that helps the AI, especially with standardized formats like doc strings that can give the AI additional context even when you're lacking a strong type system. But if you do have a strong type system, obviously leverage those type annotations, even when I know certain languages can infer types and whatnot. But when working with AIs, the more context you give it, the more explicit you can be in your code, the better that the AI is going to perform. Ironically, a lot of this mirrors working with humans, even though we say we hate some of that stuff in terms of like the writing the code. A lot of times, all this documentation and whatnot is very helpful to the other developers that we work with. So all of these things can be applied not only to making your AI more effective, but probably the other humans you work with as well. So in addition to documenting your code, build great documentation sites. Like I mentioned, granted there's a lot of money behind it, but TypeScript libraries, some of the major ones, are killing it in terms of documentation sites. And the LLMs are trained on the internet and are going and reading those documentation sites. And now with model context protocols can go out and actually read those websites in real time. So if you're building an open source tool or a library, generate some great documentation. And once again, the AI can help here. It's not all of a sudden I've got 2 weeks to code up this website. Let the AI do it. Go do a little vibe coding. This one speaks to the Ruby developer in me, but avoid magical code. As much as I love Rails, sometimes it is pretty impossible to understand where your code is actually coming from. This method just shows up out of nowhere and it works, and I don't know how, but it just does. And we run with that as developers, but that doesn't help the AI. If it doesn't know where it came from, it's not going to know how to use it. And finally, publish blogs, articles, courses about your favorite languages. Once again, the AI is your friend here. You used to have to go stand up a WordPress server and do all the things, and now you can use the AI to one, help build those sites, or you can leverage tools like Medium or other things like that. But you can also use the AI to help flesh out and edit your blog. So maybe you've always thought, like, I should publish a blog, but it just takes work, too much work. But you can dump your ideas into the AI and leverage it to actually help write those articles and courses and things like that, where you don't have to be the creator of every single letter and word in those things. And you can capture your high-level ideas and communicate them effectively to the world. And finally, this one could be difficult, but I encourage you to take a platform mindset, particularly if you're working on open source projects and libraries. As we've seen with TypeScript, the money matters. And I think other languages, I don't know this so much on us individual developers, but on companies in particular, to find ways to build tooling and make open source sustainable. And ultimately that requires money. So there's a lot of lessons to be learned from some of the TypeScript libraries out there and how they're building great tooling and also finding a way to make money besides just putting a CLI, please donate to me when you install this library. A lot of the keys here are summarized better than I could do at the link down here. I'll try to publish this on my LinkedIn or something, but this article at the bottom sort of summarizes all these concepts in way better detail than I could, so I'd highly recommend you go look at that, especially you developers that are trying to leverage AI. That's a great guide to get started. So, are we all doomed to a future of TypeScript-fueled vibes? Should we all abandon hope of ever writing in our favorite programming language again and just move to self-sustaining off-grid cabins in Wyoming? Probably not. First off, I'll charge you with the fact that I want you all to consider why you started programming in the first place. Probably a few of you out there that got into it for the money, but I know a lot of us are in it because we love solving hard problems, working with puzzles, and coding gives us that joy. So regardless of if the AI takes all our jobs, I encourage you to just lean into that passion that initially got you started in coding and find ways to work with the AI to sort of level yourself up and pursue those passions further. And then I'll leave you with the words of John Connor. He says, "The future is not set. There's no fate but what we make for ourselves." While AI is reshaping the future of software as we know it, we have the power to feed the machine and build the future we want. It isn't about one language to rule them all. It's about making our favorite languages so well documented and clearly structured that the AI has no choice but to fall in love with the languages and the tools that we love too. So get out there, strike up a conversation with ChatGPT, Claude, Gemini, whichever one you choose, and you might find that they're an ambitious learner, a great coding partner, and they just want to help you write some amazing code, regardless of the language. With that, thank you guys so much for having me.